Welcome to the first in our new series. This one we're going to focus on this brand new board from Dominic and Cleanflight. This is the Seriously Pro, and this is the new version of the board that will run with the Cleanflight software. Now, for those of you that have been watching for a little while, you'll know that Cleanflight is a software that can be installed on many flight controllers, the Flip 32, the Nazi 32, and things like the CC3D as well. This is the very latest incarnation designed by Dominic himself to overcome some of the limitations that we're all seeing with platforms like the Nazi 32. At the start of the video, I do need to say a very big thank you to Dominic himself. He actually sent me this board to do this series with on the channel, and in the videos in the series we're going to go through. The first two will be about installing the board and setting it up, and then we'll actually spend time like we did in the Nazi 32 series going and adding bits and pieces onto it, things like the GPS, sonar, LEDs and others, so that you can put everything on here that you want. The things that we'll do in this video really is first of all talk about the main advantages and differences between this and a Nazi 32, because that's what the majority of you have asked for. Then we'll talk a little bit about Cleanflight, where you get it from, how you download it. We'll install this board and set it up with the firmware, so we'll do the flashing in this first video. Then we'll install a receiver and set the receiver up so we can make sure it's all working, and then we're ready for the second video in the series where I'll actually install this board into a model. We are going to focus on the setup in this first video and those differences between this and a classic Nazi 32. The first thing we'll do is actually show you what comes in the pack. So here's the pack as it arrived to me, and looking online this is pretty typical of what you can expect to get. The first is the board inside an anti-static bag, and the second thing then is a set of pin connectors, both straight and right angled, because you'll notice here the board itself doesn't come with the pins pre-installed. Now for someone like me that is a wonderful idea, because it allows me to configure what I need and also install only the pins that I actually want. For some others that may seem a little bit daunting, but we have done some soldering examples in the Nazi 32 series, and when we get to that point I'll link to those so you can see how I do it. Take the foam out the board. That foam is actually going to come in useful. We're going to need to cover the barometer, but I'll talk about that later. You get some stickers, and then you actually get the cables themselves. Now in here we have two cables with 8 connectors on them, and those are the ones that are actually going into either side of the board for input and output, and then we have another couple here for the I2C connection, and we also have a connection for one of the UARTs as well. What you'll find with this board is that Dominic's obviously put a lot of thought into listening to everybody about the limitations with Nazi 32. The main two things that come up most often is, first of all, you can't run the LEDs when you're running lots of other things. You run out of I/O pins really quickly, and that has absolutely been addressed in the board. We'll look at the pinouts in a second. This is bristling with places for you to plug stuff into, so if you want all of the gadgets and all of the stuff turned on in Cleanflight that we'll go through in the series, you don't have to make compromises or start messing around with soft serial. You can plug it all in quite straightforwardly. The second thing is that people are using the Nazi 32 to fly hexes and getting into problems trying to use opto speed controllers. Trying to provide the plus 5 volts that a hexcopter needs is tricky when you're using all 6 of the output pins on a Nazi 32, because there's nowhere else easily to plug the inputs from the battery eliminator circuit. You can do it, but you have to get your soldering iron out. The great thing with this, it actually has 8 connections, so even if you're using a hexcopter you've got space. Even if you're using an octocopter, there are other places that you can plug the plus 5 volts into as well. Other bits that we'll talk about is the fact it's also got an I2C port, which is something the Nazi 32 doesn't have, and I2C allows you to connect some really cool stuff like OLED displays. So that's what comes in the packet. Let's talk about the main advantages then of this flight controller over other ones like the Nazi 32. It has a faster CPU. Clock speed's the same, but the CPU itself is actually a little bit more capable. It has a floating point unit, which will allow for much faster calculation, a lot more flash storage, 4 times as much data flash, no inverters needed for S-Bus. We can plug S-Bus directly into this model. In fact, I'm very tempted to do that with an X4R and the Seriously radio, so that we can have a full 16 connections into this. Has 3 hardware serial ports, and we've talked about that a little bit. Right now in the software, soft serial isn't enabled right now, but when it is, that will give us 5 ports, so we will literally be bristling with I/O. Supports the LED strip, as we talked about, without getting into problems if you're running other stuff. Has a full 8 inputs for PWM, and also a full 8 outputs for PWM as well. So if you have a larger, more capable receiver, you can do it. If you want to run an octocopter, that's absolutely something you can do with this board. The 2 things at the bottom are the ones I think that are actually most important. The first is the full feature support for all new Cleanflight features. Now, this is a list that Dominic actually sent to me that I've edited for this one, and I think that's an interesting thing that Dominic's got in here. The implication of that is that as time moves on, some of the newer features will start to be implemented that will only run on the Seriously Pro flight controller because of the limitations that are there in hardware on the NAS A32. So I would absolutely recommend make sure that you've got your Twitter account set up and you're following Dominic to track these new features as they come out. And the last one, there are 2 versions of the board available, just like the NAS A32. There's the basic and the deluxe version. The basic version is exactly the same, has all of the same features, with the exception that it doesn't have a compass or a barometer. The deluxe version does, and if you're going to want to do the GPS return to home and those kind of features as part of a Seriously Pro flight controller setup, you will need the deluxe version. The first thing I recommend you get your hands on once you've got one of these boards, or while you're waiting for it to be delivered, because they're coming into stock hopefully around now, is get hold of the manual. You can download it from seriouslypro.com, and you can get to it very easily by going into the downloads and manual area in the main menu on that website, or you can go directly by typing in seriouslypro.com/spracingf3. I'll put a link to that in the description so you can get there quite easily. It's a PDF that Dominic's written himself, and it gives you all of the information about the inputs, outputs, how to set it up, and basically the process that we're about to go through in this video. Very handy to have for reference, because each of those pages also includes all of the pinouts for all of the ports that are on this flight controller, and that's good to know when you're doing your cabling and wiring everything up. So I've actually printed out a physical copy here, and I'm going to keep that while we're doing the series. Here is one of the most useful graphics in that manual. This is the one that's actually showing where everything's connected, and as you can see, this is the top view that we're looking at here. The bottom of it is where we're going to plug all the speed controllers and servos into. The top is where the USB cable is. What I'm going to do is, rather than go through this image, which is actually from the manual itself, let me show you what it looks like in real life. Here's the top of my actual board, so you can notice the directional arrow is actually pointing towards us here. So the front of the board is the one where the ESC servo connections are. So if we go clockwise, at the very top we have the USB connector. It's a micro USB, just like a lot of the current boards. It then has the outputs for UART2 and UART1, and those are input-output ports. Then we have the input-output connections, IO2. Then we have the buzzer pins, like on the NAS A32, the boot pins, again similar to the NAS A32. We have the ESC servo connections then at the front of the board. Carrying on round, we have our connections for VBAT. Make sure you're observing polarity as you go around here. If you plug this thing in backwards and you put positive voltage on a negative rail, you will fry the board. It talks about that a lot in the manual, so be careful when you're putting this together. It's very carefully silk screened so that you have the polarity even by the side of each of the pins if you haven't got the manual handy, so there's no excuse for getting it the wrong way around. But I think there's a very distinct reason why Dominic's taken the time to do that, to make sure that we don't make a mistake. Then the next one after VBAT is the input-output connections. That is where we're going to plug in things like the input from the radio receiver. Then we have UART3, and then finally at the top we have a software debugging port that we're probably not going to use to fly with. That's there for developers. Underneath, a little bit simpler. So we have, going from the top again, there's that I2C port, which is a new addition onto this board. We don't have that in the NAS A32, but for those of you that have come to this from things like APM, Pixhawk, or even MultiWii, you'll know that the I2C is like a computer network for all of the other pieces. plugging things like an OLED display into the craft means that you can actually see exactly what's going on without connecting a computer, and the I2C port is where you plug that in. Then we have the barometer underneath. When you install this into a stack to fly with, I would always recommend that you cover that barometer with some foam. Otherwise, any stray breezes or drafts that go across that barometer will be read as a drop in air pressure, which the board will see as an increase in altitude. Then we have the back of the VBAC connectors, and then we have the ESC servo connectors that we're going to solder onto. We can see the boot pins again, the buzzer right round to the back, and there is the 4-pin connector for UART1. That's also available, as we saw at the top, as a 4-pin connection that we can solder onto. So now we've gone through that, I think it's about time we actually go to the netbook. We get hold of Cleanflight, make sure we're up to date and it's all installed on the computer, and then we'll plug in the Seriously Pro flight controller for the first time, and we'll go through the process of installing the firmware. So the first thing we need to do is to download Cleanflight. So for those of you that are coming to this board from things like the Nazi 32 and others, this will be something you already have on your PC. But if you're new to it, the easiest way to find it is just go in Google Chrome onto the Google App Store. If you just search for Google Store in Google itself, you'll get to this page. Once you're here, search for Cleanflight. You should be able to search for it as one word. However, to find it this morning, I've actually had to put clean space flight, and there you'll find Cleanflight configurator. Now what you need to do is then just say add to Chrome, and it'll download and it'll install it onto your PC. Once it's installed onto your PC, you'll be able to run it by opening the Google Chrome app and then click on Cleanflight. Now the first thing we're going to do is actually connect to the board and just make sure that it's all happy before we do anything else. So let me just put a quick insert. So this is the board on the table that we're looking at right now. I'm zoomed up a little bit, so it occasionally wanders out of focus. Apologies in advance. So we're going to plug it in for the very first time. It should connect pretty quickly because the drivers that it's using has been used for other boards. So let me plug it in. Here we go, it's booting. That's good. It shows up as COM22. Fantastic. There's the board, and if I move it around, we can see it moving on the display. Fabulous. Okay, so that means that it's working. We can also see that we have the deluxe version. We have the gyro, accelerometers, magnetometer and barometer. And again, you need the magnetometer if we're going to add and use the GPS functions later on. And we can see here that we have the 3 UARTs configured, so we'll go through those in a second. Configuration exactly like we've seen before, so that's how we need to connect the motors, and we can choose that here. But before we go through this in any detail, let's actually flash the firmware. So to do this, we'll disconnect, we'll go into firmware flasher. First of all, we need to select the firmware and board type that we have. So this is the latest version here, 1.9. All these different boards are supported. The one we want is at the very bottom, the SP Racing F3 Seriously Pro. I'm going to click on that. We need to select manual board rate. If you don't do this, it will not work. So be careful of that. If you do it without clicking manual board rate, you won't be able to talk to the bootloader. So if you can't see the bootloader, you've probably missed that step. Then we need to say load firmware online. It's going to download it from the internet. And once it's done that, it gives you all of these release notes, always worthwhile having a look through. And then finally, we're going to click Flash Firmware. We can see the red flashing light has gone out. We're in bootloader mode. We're verifying now, so it's on. We're just reading it back. Programming successful, and here it comes booting with its new version. So now if we connect again does seem to boot very fast, this board. It's really good. Then we are on the latest and greatest of everything, and now we're ready to start configuration. But before we do that, there are two things that I'd recommend that you do. The first is calibrate the accelerometer. Make sure the board is completely flat, and then click calibrate accelerometer. Here we go. Now it knows what flat feels like. And when we click on calibrate magnetometer, you then need to move the board around in all the different axes so that it's pointing in the right direction. Now I've actually just tested this and it looks pretty good. So the front of the board is here. I reckon north from where I'm sat is roughly that direction-ish. Wow, okay, that's pretty spot on, I'd say. So at the moment, I'd say the magnetometer is reasonable, but it wouldn't hurt to actually go through the configuration. I'd do those two first before you do anything else, and then the board is in a reasonable state. Ports. This is where we're going to do the configuration. The ports is changing relatively frequently as the Cleanflight versions change, so you have to keep your eye on this, and as you do upgrades, be prepared to go in and tweak things for things like GPS that we'll be doing later. Then the configuration is the main page where you're actually going to set all the board up, so you can decide what kind of frame type that you want here, and it'll show you not only the motors but the direction they want to move in. Now we're going to pop it onto a good old-fashioned quad X. That is how we need to connect the motors. So motors 1 and motors 4 both turn clockwise, motors 2 and motors 3 turn anti-clockwise, and what we're going to have to do is when we come to that point of plugging it into the model, we'll have to plug in the ESCs for the motors that way, and then we'll test them. I don't like the motors to spin when it's armed. That's just a thing for me. That's a very personal choice. The disarm bits and pieces, we're going to have an S-bus connection for this one. We're going to use an X4R receiver, and through the series we'll also set up the smart port telemetry as well. So we'll do that when we come back. At the moment, that's all we need to worry about in here. We'll spend a lot of time back doing things with things like GPS, soft serial, telemetry, LED strips, potentially even fitting an OLED display in the series as well. But for now, we'll just save and reboot. And what we'll do is we'll actually go and stop the video there. We'll install our X4R onto the board itself, and then we'll come back and we'll actually make sure that all the receiver pieces are working. So the first thing we need to do is actually plug the X4R receiver, which is going to provide the S-bus signal, into the board. Now there are 2 or 3 common ways that we can actually put the board together with a receiver. There's S-bus, which we're using here. There's also CPPM or PPM, and there's also PWM. Now I'm not going to have time to cover all of them in this video, so we're just going to set up my S-bus receiver here, but the next video in the series is actually a quick tip that goes through the setup for each of those 3 things, PWM, PPM, and we'll recover the S-bus that's in here. The trick here is that you need to have a look at the cables that come with the kit. So not these ones that we use for the ports, but these 2 big ones that have the connectors in that go into either side, IO1 and IO2. You'll notice that one of them, the 3 wires that come off for ground, plus 5 volts and signal, are connected into individual servo connectors. The other cable that comes in the kit is slightly different. In this one, the first 3 wires that come off the ground, plus 5 volts and signal, go into a single servo connector. This is the one you want to make sure you've got in your hand when you're plugging your receiver in. So if we are going to install it in S-bus, the easiest way to do this is to install the cable into IO2 like that. So it's on that side of the board, and then to plug that cable that has the 3 wires in it, the red, black and white, into the S-bus signal for our X4R. Be very careful, we're observing polarity, and on an X4R it actually goes on that SB output. So that is how we need to configure it. Now what we'll have to do here is we'll also have to apply power to the X4R when we plug all this back into the PC in a second. So what I'm actually going to use, a little battery eliminator circuit, and I'm just going to plug that into one of the other ports, and I'm going to connect that up to a LiPo. When I connect that up to the LiPo, everything's going to power on, because the power is going to come into the receiver and then back out the receiver into the board. So let me just show you what that looks like. There we go, so the board's booting. So now we can go back onto the PC, go back into Cleanflight, and actually show you what you need to do to configure SBus so that it's working. So back on the netbook now, we're not actually connected to the board this time, so I'm just going to plug the USB cable into that board that we've just powered using the LiPo battery. So here I'm plugging it in now. We'll connect to the board. And there are actually three things that we need to do in order to get SBus working. The first is we need to go into ports and select UART3 to be a serial receiver port. So we need to make sure that that box is ticked and then click on save and reboot. The board will then reboot, and the next step is we go into configuration. We go all the way down to the receiver mode, and there are two things we need to do in here. One, we need to select receiver serial. That will tell the board that we want to use Spectrum satellite receiver, SBus, SUMD, whatever. The thing you have to remember, as well as selecting that, you also have to pick the serial receiver provider in here. If it's Spectrum, you're going to have the top, SUMD is underneath it. We obviously want to highlight SBus. Make sure that you've got RX serial and SBus connected. Then click save and reboot again. And then when you go into the receiver tab, there are all the channels. If I move my throttle, if I move my rudder, my elevator, and my aileron. So they're all working. Make sure, if you're not getting the right controls on the right channel, that you have the right channel map selected. On something like a Taranis, you can choose it. So you want to make sure that you have aileron, elevator, throttle, rudder, auxiliaries 1, 2, 3, 4 in that order. Now we're ready for the next step, which is actually to go back to the board and start soldering things on, putting it into a model and configuring the ESCs and motors, and then finally having our first test hover. So the next video in the series will be a very quick tip that will go through how you also connect all this up if you're looking to use a different style receiver, things like a PPM or a CPPM receiver, or even a PWM receiver. So we'll go through some of these options in the next video in case you're not using SBus, and then the second proper video in the series will actually go through and we'll do that soldering, connection to the motors, final configuration. We'll have a look at some of these tabs, and then we'll go and fly. Thank you for taking the time to watch that video. There are lots of other videos on the channel, and they're carefully ordered into playlists, so you may find that there are other videos on this same subject that you can go and watch. So I would recommend going into the playlist area of Painless 360 YouTube channel and looking around and seeing what there is. You never know what you might find. Thanks for watching. Please like, subscribe, and happy flying.